Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equation with variable equation. So, we are given a Cauchy's equation. Let's get going. Problem. Solve x cube d cube plus 3x square d square plus xd plus 1 into y equal to x log x. We are given a differential equation with variable equations. And also we are given a Cauchy's equation. X cube d cube plus 3x square d square plus xd plus 1 into y equal to x log x, right? Now, we have to reduce the given differential equation with variable coefficients to a differential equation with constant coefficients by making some substitution. Let x equal to e power z, then log x to the base equals to z for x greater than 0, and also theta equals to d by dz, then xd equal to theta x square d square equal to theta of theta minus 1, or theta into theta square minus theta into 1 theta x cube d cube equal to theta of theta minus 1 into theta minus 2. Since we are having theta into theta minus 1 is theta square minus theta, so replace theta into theta minus 1 with theta square minus theta into theta minus 2 equal to theta square into theta is theta cube minus 2 theta square minus theta into theta square minus into minus plus theta into 2 theta, which is equals to theta cube minus 2 theta square minus theta square is minus 3 theta square plus 2 theta. So we can write theta of theta minus 1 into theta minus 2 as theta cube minus 3 theta square plus 2 theta. Here theta is a differential operator with independent variable z. Okay. Now the above equation becomes replace x cube d cube by theta of theta minus 1 into theta minus 2 plus 3 into replace x square d square by theta of theta minus 1 plus replace xd by theta plus 1 into y equal to replace x by e power z into replace log x by z. We have theta of theta minus 1 into theta minus 2 is theta cube minus 3 theta square plus 2 theta plus 3 into theta of theta minus 1 is theta square minus theta plus theta plus 1 into y equal to z into e power z, right? Then theta cube minus 3 theta square plus 2 theta plus 3 theta square minus 3 theta plus theta plus 1 into y equal to z into e power z. Here minus 3 theta square plus 3 theta square gets cancelled also. 2 theta plus theta is 3 theta plus 3 theta minus 3 theta gets cancelled. Okay. Then we'll get theta cube plus 1 into y equal to z into e power z, right? So we have reduced the given differential equation with variable coefficients to a differential equation with constant coefficients. Now we need to find the general solution of the given differential equation, which is given by y equal to yc plus yp. Firstly we will find yc and later we will go for yp. So let's find yc using the auxiliary equation. So we got theta cube plus 1 into y equal to z into e power z, right? Which is an operator form. F of theta into y equal to some function of z, where f of theta is theta cube plus 1. Okay, now let's find yc using the auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we are having f of theta equal to theta cube plus 1. Let's replace the differential operator theta by m, so that we'll get f of m equal to m cube plus 1. Now our auxiliary equation becomes m cube plus 1 equal to 0. Now we'll find roots of this equation using synthetic division method. Now consider polynomial m cube plus 1. Let's see which m satisfies this polynomial. For m equal to 1, minus 1, 2, minus 2 and so on. Okay. So when m equal to 1, we'll get 1 cube plus 1, which is equals to 1 plus 1, 2, right? Not equals to 0. So m equals to 1 does not satisfy this polynomial. And also obviously we know that m equal to minus 1 satisfies this polynomial, right? Because 1 cube is minus 1. Sorry, minus 1 whole cube is minus 1. We'll get minus 1 plus 1, which is equals to 0. So m equal to minus 1 satisfies this polynomial. Now coming to synthetic division method. Okay. Firstly, place the values. Quotient of m cube, sorry, m power 0 is 1, m power 1 is 0, m square is 0, and quotient of m square is 1, right? Now since m cube plus 1, we are having polynomial m cube plus 1 and minus 1 satisfies this polynomial. So for m equal to minus 1, we'll proceed this synthetic division for m equal to minus 1. Firstly, 1 plus 0, 1, minus 1 into 1 is minus 1, 0 minus 1 is minus 1, minus 1 into minus 1 is plus 1, 0 plus 1 is 1, minus 1 into 1 is minus 1, minus 1 plus 1 gets cancelled and you'll get 0, right? And also this gives a polynomial m square minus m plus 1, right? And also here we are having m minus 1, m equal to minus 1. From this we'll get m plus 1 equal to 0. So we can write m cube plus 1 as product of 1 factor m plus 1 into polynomial m square minus m plus 1, right? Okay. Now we can write this auxiliary equation as m plus 1 into m square minus m plus 1 equal to 0, right? Now equate each factor to 0 to find roots. See, by considering the polynomial from this step, we won't get roots directly. Okay? See, if you want, you can try for m equal to 1, 2, minus 1, minus 2 and so on. Let's try for 1. We'll get 1. If we try for minus 1, 1 plus 1 plus 1, which is equals to 3. It is, it will be a little complex to find the roots using this polynomial. Okay, so we'll use quadratic formula to find roots from this polynomial. Okay, firstly equate each factor to 0. I am equating each factor to 0. M plus 1 equal to 0. m square minus m plus 1 equal to 0. From m plus 1 equal to 0, we'll get m equal to minus 1, 1 root. And from this equation, we'll just compare with the quadratic equation in m. So that we'll get a equal to 1, b equal to minus 1, and c equal to 1. And let's use quadratic formula now to find m from this equation. Minus b plus or minus square root of b square minus 4ac by 2a, which is equals to minus of minus 1 plus or minus square root of b square minus 4ac by 2a, 2 into 1. This is equals to 1 plus or minus square root of minus 1 whole square is 1, minus 4 into 1 is 4, by 2 into 1, 2, right? Which is equals to 1 plus or minus square root of minus 3 by 2. Now we can write this as 1 plus or minus, write minus 3 as minus 1 into 3. This is equals to 1 plus or minus. Now split square root of minus 1 into 3 as square root of minus 1 into square root of 3 by 2. Since we know that square root of minus 1 is I, then this becomes 1 plus or minus I root 3 by 2, or 1 by 2 plus or minus I into root 3 by 2, a complex number, right? So when m plus 1 equal to 0, we'll get m equal to minus 1. When m square minus m plus 1 equal to 0, that is from this second factor, we'll get 1 by 2 plus or minus I into root 3 by 2, right? This is a real root and this is a complex root. Therefore, we got roots, right? Roots of our auxiliary equation. Therefore, minus 1 is a real root and 1 by 2 plus or minus I root 3 by 2 is a complex conjugate root. We know that when a plus ib is a complex number, its conjugate is a minus ib. Likewise, if a minus ib is a complex number, its conjugate is a plus ib, right? So we'll call a plus or minus ib as a pair of complex conjugate roots, right? When m equal to a plus or minus ib, we'll have yc equal to e power az into c1 cos bz plus c2 sin bz. But firstly, we are going to write for minus 1, right? So when you have a real root, we'll get, or we can write yc as one constant into e power, that real root, say some m1 into z. Okay, so firstly we'll write for real root and then we'll go for a pair of complex conjugate roots. So let's change the constants here, c2 as c2 and c3 for our convenience. Okay, now coming to complementary function. Yc equal to, let's write for minus 1 firstly, we'll get c1 e power minus 1 into independent variable plus, now we are going to write for this pair of complex conjugate roots, we'll get e power. Now just compare 1 by 2 plus or minus I root 3 by 2 with a plus or minus ib, then for a equal to 1 by 2 and b equal to root 3 by 2, we'll get e power 1 by 2 into z into one constant into cos b root 3 by 2 into z plus c3 sin root 3 by 2 into z. Then yc becomes c1 e power minus z plus c2 z by 2 into, sorry, e power z by 2 into c2 cos root 3 by 2 z or root 3 z by 2 plus c3 sin root 3 z by 2. Okay. Or see, you are having yc in terms of z, but we need to write in terms of x. So what we'll do is we'll just write e power az as e power z whole power a, and then replace e power z by x and z by log x. Okay. From this you can write directly yc equal to c1 e power z whole power minus 1 plus e power z whole power 1 by 2, because e power a into z is e power z whole power a. Okay. Into c2 cos root 3 by 2 into z plus c3 sin root 3 by 2 into z. Or from here you can write e power minus z as e power z power minus 1 plus e power z by 2 as e power z whole power 1 by 2, because here a is 1 by 2, right? Fine. Now just replace e power z by x, then we'll get c1 x inverse plus x power 1 by 2 into c2 cos root 3 by 2 into, replace z by log x, we'll get root 3 by 2 into log x plus c3 sin root 3 by 2 into log x. Okay. Or we know that x inverse is 1 by x, then we can write c1 into x inverse as, the first term as c1 into 1 by x, which is equals to c1 by x, right? So the first term becomes c1 by x plus, also we know that square root of a equal to a power 1 by 2. Then we can write x power 1 by 2 as square root of x into c2 cos of root 3 by 2 into log x plus c3 sin of root 3 by 2 into log x. Okay. This is our required yc. So we got yc. Now let's find yp. Now coming to particular integral. We'll find particular integral using yp equal to 1 by f of theta into q of z. We are having f of theta, theta cube plus 1, and q of z is z into e power z. So this is of the form 1 by f of theta into e power az into some v, right? We'll shift e power az towards left by replacing theta with theta plus a. And later we'll operate v with 1 by f of theta plus a. Now just compare e power z with e power az, then for equal to 1, we'll find theta plus a, which is equals to theta plus 1. Now shift e power az towards left by replacing theta with theta plus 1. We'll get theta plus 1 whole cube plus 1 into z. Okay. Now we'll expand theta plus 1 whole cube using Pascal triangle. 1, theta plus 1 whole cube equal to theta cube plus 3 theta square plus 3 theta plus 1. So YP becomes e power z into 1 by expansion of theta plus 1 whole cube is theta cube plus 3 theta square plus 3 theta plus 1 into z, which is equals to e power z into 1 by theta cube plus 3 theta square plus 3 theta plus 1 2 into z. See, this is of 1 by some function of theta into z power k form, right? So here we'll take the lowest degree term common from all the 4 terms. Okay. The denominator is in decreasing order and we'll take the lowest degree term common from all the 3 terms. Since we don't have 2 in the first 3 terms, so we'll multiply and divide 2 to the first 3 terms so that it will be easy to take 2 common from all the terms in the next step. Okay. This becomes e power z into 1 by, now multiply 2 to the first 3 terms, multiply and divide 2. Okay. 2 by 2 into theta square plus 3 theta square plus 3 theta plus 2 into z. Now take 2 common from these 2 terms, we'll get e power z into 1 by 2 times theta cube plus 3 theta square plus 3 theta by 2 plus 1 into z. Now we can write this as e power z into 1 by 2 into 1 plus theta cube plus 3 theta square plus 3 theta by 2 into z. Okay. Now split this fraction into 2 fractions. We'll get 1 by 2 into 1 by 1 plus theta cube plus 3 theta square plus 3 theta by 2 into z. See, the second fraction is of 1 by 1 plus x form, so we can write it as 1 plus x whole inverse. Okay, then this becomes e power z by 2 into 1 plus theta cube plus 3 theta square plus 3 theta by 2 whole inverse into z. Now we'll expand this using binomial series expansion formula. 1 plus x whole inverse equals to 1 minus x plus x square minus x cube plus so on. Okay. So before expanding this using binomial series expansion formula, we'll find the derivatives of z with respect to z. Theta of z is 1, derivative of z with respect to z is 1, right? And theta square of z is, we can write theta square of z as theta of z. We already have the value of theta of z, which is 1. Now find derivative of constant with respect to z, which is 0, right? Likewise, we'll get theta cube of z is 0 and so on in general. Theta power k of z is 0 for k equal to 2, 3 and so on. Okay. So keeping this in mind, we'll expand 1 plus this term whole inverse. Let's now expand 1 plus theta cube plus 3 theta square plus 3 theta by 2 whole inverse. Using this formula, we'll get 1 minus of theta cube plus 3 theta square plus 3 theta by 2 plus theta cube plus 3 theta square plus 3 theta by 2 whole square minus plus and so on. This equals to 1 minus 1 by 2 into theta cube plus 3 theta square plus 3 theta plus 1 by 2 square is 4 into expansion of, or just write theta cube plus 3 theta square plus 3 theta whole square, okay, minus 1 by, in the next step, in the next term we'll get theta cube plus 3 theta square plus 3 theta by 2 whole cube, right? From this we'll get 1 by 2 cube into theta cube plus 3 theta square plus 3 theta whole cube. So I'll just write plus minus plus minus plus and so on. Let's now find expansion of this term. Since we know that a plus b plus c whole square equal to a square plus b square plus c square plus 2ab plus 2ac plus 2ca. Okay, 2bc plus 2ca, right? Theta cube plus 3 theta square plus 3 theta whole square equal to a square, that is theta cube whole square plus b square 3 theta square whole square plus 3 theta whole square plus 2ab, 2 into theta cube into b 3 theta square plus 2bc, 2 into b into c 3 theta plus 2ca, 2 into c into a. So we'll get higher derivatives here. This is equals to, we know that a power m whole power n equal to a power m into n, right? Then we'll get theta cube whole square as 3 2s are 6, theta power 6 plus 3 theta square whole square is 3 square 9, theta square whole square is theta power 4, 2 2s are 4 plus 3 theta whole square is 9 theta square plus 2 3s are 6 into theta cube into theta square. Add the powers, 3 plus 2 you'll get theta power 5 plus 2 3s are 6, 6 3s are 18 theta power, add the powers, 2 plus 1 3 plus 2 3s are 6 into theta power, add the powers, 1 plus 3 is 4. So you got higher derivatives, theta square, cube, power 4, 5, 6. Since we know that theta power k of z is 0 for k equal to 2, 3 and so on, because theta power k of z is 0, that is derivative of z is 0 for k equal to 2, 3 and so on. Okay, higher derivatives from theta square, higher derivatives of z from square is 0. So we can neglect all the terms from here. Since all the higher derivatives from here is 0, so we'll neglect all the higher derivative terms from here. Okay, because we know that from the third term we'll get higher derivatives. Okay, so we'll take only the first two terms. Now coming to yp, we'll write it as e power z by 2 into expansion of 1 plus x whole inverse is 1 minus of theta cube plus 3 theta square plus 3 theta by 2 plus theta cube plus 3 theta square plus 3 theta by 2 whole square minus plus and so on into z, right? This equals to e power z by 2 into 1 minus 1 by 2 into theta cube plus 3 theta square plus 3 theta plus 1 by 2 square into theta cube plus 3 theta square plus 3 theta minus so on into z, right? This becomes e power z by 2 into 1 minus 1 by 2 into theta cube plus 3 theta square plus 3 theta plus 1 by 2 square is 4 into, say this is square, okay? Because theta cube plus 3 theta square plus 3 theta by 2 whole square is 1 by 2 square into theta cube plus 3 theta square plus 3 theta whole square, okay? Expansion of theta cube plus 3 theta square plus 3 theta whole square is theta power 6 plus 9 theta power 4, okay, 6 theta power 5 plus 9 theta power 4 plus 6 theta power 5 is 15 theta power 4, 9 theta power 4 plus 6 theta power 4 is 9. 15 theta power 4 plus 18 theta cube plus 9 theta square, okay, minus so on into z. Since theta power k of z is 0 for k equal to 2, 3 and so on. So neglect theta square, theta cube and so on. So we are going to neglect all the terms from here and also the term involving theta square and theta cube from the second term, because theta cube is highest derivative and highest derivative of z. Theta cube of z is 0. Likewise, theta square of z is also 0. So we will neglect theta cube and theta square from the second term. Then we will get 1 minus 1 by 2 into 3 theta into this z. Okay. This becomes e power z by 2 into 1 minus 1 by 2 into 3 theta into z, right? This is equals to e power z by 2 into 1 minus 3 by 2 into theta into z, which is equals to e power z by 2 into z minus 3 by 2 into theta of z, which is equals to e power z by 2 into z minus 3 by 2 into theta of z is 1, which is equals to e power z by 2 into z minus 3 by 2. Now we are having yp in terms of z, but we need to write in terms of x. Or firstly we can take the LCM of 1 and 2. You'll get 2z minus 3 by 2, right? This is equals to e power z by 2 2s are 4 into 2z minus 3. Now just replace e power z by x and z by log x. Then we'll get yp equal to x by 4 into 2 log x minus 3. This is our required yp. Okay. Or we can write it as 2x log x by 4 minus 3x by 4, which is equals to x log x by 2 minus 3x by 4. See, we got yc and yp. Let's now write the general solution. The general solution is given by y equal to yc plus yp, right? Then y equal to yc, we are having c1 by x plus root x into c2 cos of root 3 by 2 log x plus c3 sin of root 3 by 2 log x plus yp. So firstly I'll write for this plus x by 4 into 2 log x minus 3 or y equal to c1 by x plus root x into c2 cos of root 3 by 2 log x plus c3 sin of root 3 by 2 log x plus yp. X log x, this one, by 2 minus 3x by 4. This completes the problem. So we have seen a problem from Cauchy-Euler equation in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.